All right, so in our efforts to solve this 3 by 3 system, we arrive at the following characteristic polynomial, which is negative lambda cubed minus 6 lambda squared minus 11 lambda minus 6 equals 0. And at this point, the best thing to do is now get a graphing calculator and draw a graph and see where it crosses. And when you graph this polynomial, you'll notice that it crosses at one location for sure, which is lambda equals -1. So if lambda is equal to -1, we can use synthetic division to reduce this down to a smaller degree polynomial. All right, so we'll bring down the -1, multiply, add, multiply, add, multiply, and add, and we do get remainder 0. So we know that our polynomial is going to have a lambda plus 1 as a factor because the -1 is a root. And then we're going to have a negative lambda squared minus 5 lambda minus 6 is equal to 0, which factors as a negative lambda plus 1 lambda squared plus 5 lambda plus 6 equals 0. And then we can see that that last part of this does factor as well. So we get negative lambda plus 1 times lambda plus 2 and lambda plus 3 is equal to 0. So we get 3 distinct values of lambda. We've got -1, we've got -2, and we've got -3. Just kind of a coincidence. They don't have to be the same consecutive numbers like this. All right, so the next step for us is to now go in and find the corresponding eigenvectors for each one. Remember again that when you're finding the eigenvectors, you are subtracting that value of lambda off of the main diagonal. So for our matrix A, when you subtract a -1, you're actually adding 1 to get those new numbers. So -6 plus 1 makes -5, -1 plus 1 makes 0, and 1 plus 1 makes 2. And then the other numbers in the matrix are going to stay exactly the same. So 2, -3, -1, -1, and 4. The next step is to go to our graphing calculator and put this into row reduced echelon form. And again, we're just working with the 3 by 3 part of this. So we got a -5, a 2, a -3, a -1, 0, -1, 4, and that should be obviously a -2 down there. -2, and finally a 2 at the end. And then once that matrix is entered in, you do the row reduced echelon form, and that form is going to be 1, 0, 1, 0, 1, 1. And then you have a row of zeros. And again, that row of zeros is key because it tells us that we have the correct eigenvalue. Again, this is times the V1, V2, V3 equals 0, 0, 0. And this gives us our relationship between our components. So the top row says that 1 of the V1s plus 0 V2 plus 1 V3 equals 0. Implies that V1 is equal to the opposite of V3. The second row says that 0 V1 plus 1 V2 plus 1 V3 equals 0. That tells us that V2 is also equal to -V3. So putting this back together again, our vector V with components V1, V2, V3 is equal to -V3, -V3, and V3. Factoring out the V3 gives us a -1, -1, +1 eigenvector corresponding to lambda1 equals -1. So in the next video, we're going to go through and find the other 2 eigenvectors for this matrix as well.